Okay, so my name's Cole Kepner. This is lab number 2. Because I only have 5 minutes, I'm going to go pretty quick, but slow it down, I guess, to hear what I'm saying. Introduction. So this is the exact same stuff we did in lab 1, except we then changed the model of the tape from a point charge to a collection of point charges spread across evenly along the tape into basically a line charge. You'll see graphically this in the next slide. But basically what we want to do is just investigate the interactions of the tape and kind of see firsthand the charges necessary to cancel out a force of gravity. Um, Basically what happened is it floated and both tapes have negative charge and obviously they repel. We originally calculated this point charge to be negative 5.6 times 10 to the negative 9 coulombs, but with the line charge approximation, we found that to be a greater value of negative 1.3 times 10 to the negative 8. Main physics principles. So over here on the right, you can see the computational model that I developed in code. Um, this image right down here is basically just of the experiment we did in lab. And then we kind of looked at Newton's first law. Basically, when nothing's moving, there are forces that are balanced. Gravitation, electric fields over here, line charge approximations, and then electric force equation, but in its little infinitesimal form. Experiment procedural. I went over this in my last, back. In the last lab video, basically it's just we set the tape, put on two erasers, and then kind of balance the tape on top of it. I don't want to go into too much detail because it's not exactly too relevant to this lab because it's already been covered in the last lab. Calculation process, same goes for this slide as well. This is just deriving where we got our original point charge number. But because we're approximating as line charges, this number is not too relevant now. System was the two pieces of tape, but specifically the top piece of tape where the surroundings um, was the bottom one. And that's because the bottom one is acting on the top one. Um, and then the initial conditions, separation distance 1.5 centimeters, tape length 13 centimeters. Code. So I use the model shell code provided by Dr. Recco. Um, Basically just changed a few of the numbers. Q, this is the number that we had. This mass is the tape mass we had of, I think it was 0.13 grams. See, change there. Over here, this 0.15 is going to be the separation distance. And then these two numbers were just scaled visually for the model to basically be seen. And then down here, this equation was basically derived to get that force. And then this is also just to create the vector to see the force. More code. This is just to see the two arrows, kind of applying the vectors that we just derived. Now, what if? What if the tapes were point charge versus line charge? You can kind of see the value here and the difference. Obviously, this one is greater. In the very first slide, I'll go back to it real quick. This white arrow is a lot smaller than this yellow arrow, and this was developed, and this model was basically done using that point charge approximation. So if I change it to this 1.3 value, those arrows will be equal and it would balance out. Basically, what that's saying is they differ because the line charge approximation is using more points along that tape to approximate and is more accurate as a result. Because if you basically treat the tape, which is spread out charges, as only one charge in the center, it's not going to be very accurate. But if you get closer to that by spreading out charges across it, it's a bit more accurate. Now, possible error. Similarities, I mean, forces canceled, and because the force canceled tape floated. Differences and assumptions we made. The model treated tape as a collection of point charges. I just covered that in the last slide. And then error resistance was ignored. This is a small caveat. It wasn't actually ignored in the calculations, but in the kind of model itself, as the tape kind of rises to float, it doesn't count error resistance, but that's so negligible. We can kind of ignore that. And I mean, because we're treating this as an equilibrium, error distance is not really needed in that calculation at all. Possible error, human error and separation distance. Also, charging the tapes could be different as we're ripping it off the table. And then also, obviously, there's a huge difference because we are treating the point charges as finite when in reality it is an infinite collection. Um, Not splitting up the tape into an infinite number of small pieces instead of just 10, as what I use in the code. Anyway, that is all. Thank you very much.